Hey, this is Will with SRT Amplification. How are you guys doing? I'm inside my wife's Jeep Liberty and she's got an electrical problem. So right now I'm not doing very many repairs or anything on my bench because right now I'm in the process of moving my bench to another location in the house, getting it out of the garage. And so while all that's going on, I hadn't been working on anything, but we ran across an issue with my wife's Jeep Liberty a couple of weeks ago. I've already troubleshot it and fixed it, but I wanted to go over the procedures that I took to find it. And I thought I'd make a good video, so we're going to do that today. And so yeah, that's what we're going to do. So let me tell you a little bit about what's going on here. Like I said, this is my wife's Jeep Liberty, and it had some parasitic current draw, parasitic load. Even when it was off, 3 or 4 days, it wouldn't start. The battery would be completely drained. So at first I suspected a bad diode on the alternator. And I'll show you how to check your alternator to see if your alternator's working or not at the end of this video, but it wasn't the alternator. And so then I just had to do a systematic approach of figuring out what it was, and then I finally found it, and now it'll go. I haven't let's see, I let it go about 4 days and it started up just fine, and now I've let it go 7 days and it started up just fine. So it wouldn't go past 4 days before, so I'll let it go a little bit longer this next time and we'll see. But as you can see, when we do this procedure here, you'll see where the parasitic load comes in, and we'll talk about that. So let's go look underneath the hood. Well, first of all, one thing you have to do when you're troubleshooting a parasitic load on your car battery is you have to put it through the conditions that it's normally going to be. So in other words, you have to, so when it would die, when it would drain the battery, I would pull it into the garage, shut it off, and then 4 days later or whatever, come back out, and then it'd be dead, right? So you have to let it go through that process. What I mean by that is, if you go and you disconnect the battery to do your troubleshooting, to put your meter in series, you kill some of the processes that go on. Okay. Now, in my situation, the reason for it probably wouldn't have mattered. But I'm telling you, I'm going to take you through the procedures on how to do it properly, because there's some things that don't go off right away. They stay on, like your computer. It stays on for about, your PCM, it stays on for about 5 minutes or so, and it draws current. So you have to get to that state to where it shuts off, and then there's other things that may be manifesting itself as problems that you won't see if you don't do it the way I'm about to tell you, about to show you how to do it. So let's get underneath the hood and I'll take you through it. Okay, so I just shut the Jeep off, right? And so it's doing its thing, whatever, the PCM is probably still drawing current. One thing you need to make sure that you don't have any doors open or anything like that, because it's going to keep some lights on inside the cab, and you don't want any of that. So the best thing to do, I have found, and yeah, you have to pardon my little clamp job here, as you can see. Let me zoom you in here. You have to pardon my little clamp job there. I've got to get that fixed. As you can see there, that's okay. So what you want to do is you always want to work on the negative side of your battery. Okay. The rule on working on batteries is you always disconnect the negative first and reconnect it last. And that is because if you're taking off the positive terminal and you hit your wrench up against the chassis and this is still connected, then you're going to arc. You're going to draw a big arc with your wrench. Okay, so you don't want to do that. So we need to make a series connection. So you can make a series connection taking either one off, but it's safest to do the negative. Okay, so we're going to do that. And again, like I said, I've got this botched thing right here. I need to fix at some point, but that's really not the purpose of this video. So let me get this thing off. Now what you want to do with your, okay, we're going to go ahead and pre-set up our meter here, okay? And what I've got on the meter is I've got clips, okay? And took the probes off and I put these little clips, these little alligator clips on, okay? So what I'm going to do, I'm going to put one, like I said, you need to maintain your connection here, okay? I'm going to put one there, and what I'm going to do for this one, I'm going to clamp this with the battery charging clamp, okay? And that's just going to give me something to clip onto here with the other one. Okay, so I got that one clipped here, got that one clipped here, okay? All right, so you can just take this off now. Well, let me get the meter set up where you can see it. Now, usually it takes about 5 minutes for the PCM to go off, so it may have already gone off while I've been fiddling with this. We'll see. You want to set it to the 10 amp range on your meter. Did you see there? 10 amps. Make sure that your lead is in the 10 amp lead. Now, it's not going to be 10 amps on here, hopefully. Yeah. So now we can take this thing off here. This little botched thing I got here. I know I need to fix this, but this is how I had to do it. So now when I pull this apart, you see I've got current flowing through here already, okay, because I've already made the disconnection. See, I've got 520 milliamps, okay, 520 milliamps running through here. You see how I got this? I got the black one on there, this is off, red one on there, it's in series, 520 milliamps. Now when the PCM cuts off, you'll see it here in a minute, it should cut off, and if it takes a little bit longer than 30 seconds or so, I'll just cut the tape, cut the film in and show you. But we can pull this out here to the side here, get it out of our way. We just don't want this touching back on the battery. Okay, so there we go, 530 milliamps. Now if you got 530 milliamps running through your battery all the time, it's not going to take long for that thing to drain. Okay, not long at all. Another case in point, while you have this set up right here with your meter in series, okay, do not attempt to start the car. Okay, and in fact, don't do anything to the car. Don't put any load on it whatsoever. If you attempted to start the car right now, the way I have it, the meter, the probes, the leads, everything in this series circuit right here is going to be destroyed. Okay, you see it starting to drop right here. So we just lost something turned off. It's down to 470 milliamps. Okay, here in a minute something else is going to drop off. You have to wait before you start pulling fuses out of your fuse box, which we're going to do right now. You have to wait. Okay, you have to wait till this gets down. It usually takes about 5 minutes, and we're getting really close to 5 minutes from when I shut the engine off. So let's see what we got here. Now I have put the fault back in here. I have put the faulty component fuse back in this box. Okay, so it's in here. So when we get to this, I'm just going to go straight to it. I'm going to show you how to pull these fuses out one by one and check them. and we'll look at the meter, but I'm just going to go straight to the, well, we may pull one out that I know is good, but then the other one, I'll go straight to it, okay? So we're at 470 milliamps. This needs to be running at no more than 50 milliamps, and it should be probably between 20 and 40 milliamps is what it should actually be running at, unless you got a problem. I would say under 40 milliamps is probably what it needs to be at. But right now we're over 10 times that, you know, like 12 times that right now. Okay, so let's see what's going on here. We're still at 470. Do I have any lights on? No lights on. Okay, you always got to check that kind of stuff. No lights on. You don't want to have your trunk open or anything like that. Okay, so it took about 8 minutes, so I cut the film off there, and so between 5 and 10 minutes that PCM is gonna drop out. So you can see we're still at 90, 80 or 90 milliamps. Now at this point you could go down to the milliamp range, but you're gonna have to break connection to do that, and some of your faults that may be lurking, you won't be able to find. So what I'm going to do without even changing anything, just keeping this in series, I'm going to open up my box here, reposition this so you can still see it, but you see I got 80 milliamps. Okay, open up my box here, and what you're going to do is you're going to go through and pull each one of these, just starting a line all the way down, each one of these modules, fuses. Okay, there's some that are in modules like this one, this line here, and there's some that are just individual regular automotive fuses, right? You just go through there and pick each one of them out, right? So what I'm going to do is, this is hard holding this camera and everything. I'm gonna pull this one out. I'll just pull a random one out. Let you see. Now there is a special fuse holder for these. I don't like them. They're not very good. But you can see I pulled that one out. If you use needle nose pliers like this, just don't press really hard and crack that plastic on that fuse. Okay, that didn't do anything. You're gonna do each one of these. Just go through right in a line and then stick it back in there. So the one that's the question is this one right here, and watch when I pull it out. You see it went down to 40 milliamps. So something in this circuit was drawing 40 milliamps, or you know, maybe close to 50 milliamps. And what this circuit is, it's the motor for the back windshield wiper. So more than likely there's some winding shorted in that back windshield wiper, and even with it off, it's causing a current draw on it. So I just keep this fuse right here. You know, a lot of cars don't have rear windshield wipers anyway, so just pulling that out has seemed to solve the problem, or at least, you know, keep it from dying within 4 days. There's still 40 milliamps out there somewhere. I have pulled every one of these out and nothing goes away. It stays at 40 milliamps regardless. So I guess that's about what it is. Now that may be one of these relays, could be drawing that. I did not pull out any of the relays. If I see that this thing is not going to start after, you know, maybe 2 weeks of sitting, maybe, then I may do a little more exploring to find out where that 40 milliamps is coming from. But so far it hasn't been a problem. So main thing is you need to troubleshoot these exactly the way you leave them. So you need to shut the car off, remove the key, come over here, hook it up the way I did, hook it up where it's going to be in series. Once you disconnect it on the negative, disconnect it with the meter in series, and then watch that meter until you see a large current fall off of it, and then, you know, maybe I'd give it, you know, maybe 10. I'd even maybe wait 15 minutes. And then if you still have anything more than this 40 milliamps on there, then go through and pull each one of your fuses and see where that gets you. So that's what I found on this one. Now I'm going to hook this back up. Well, first of all, I'm going to show you how you know if the alternator is good or not, okay? So let me set that up for you. Okay, to see if your alternator is good, what you're going to do is you're going to get a voltage reading on the battery without the engine started, without the alternator on. So put your negative lead on the negative terminal, positive lead on the positive terminal. Have your voltmeter set to a range that's going to be higher than, you know, about 16 volts. Is going to get up to about 14 something if the alternator's working. So right now we're reading a battery voltage of 12.5. That's good. That's what a battery is probably going to read. A good charged battery. Now, just because a battery reads, you know, 12 volts or higher, doesn't mean that the battery is capable of starting your vehicle. Okay, so you could have a 12 volts across there and it still not have the capability of providing enough current to start your engine, but hopefully it starts. We're going to start the vehicle, and then we're going to come back out here and we're going to look at the meter again, and you'll see right away if the alternator is working or not. So let's start the vehicle. Okay, so the alternator's putting out about 14 volts. So that tells you right there that it's charging. And if the battery was really discharged, that voltage would be up around almost close to 15 volts. It'd be like 14.5, 14.6, even higher maybe. But right now you can tell it's the battery's got a really good charge on it. It started right up. You can see the voltage is starting to taper down. The alternator sensing is not putting as much voltage out because it doesn't need it. The battery's pretty much fully charged, except for what I just did to start the engine, right? So anyway, that's that. Alternator's good. If for some odd reason, and this may be the first thing you want to check the battery voltage, start it up with it connected, and see if that voltage doesn't come up to, you know, up into the high 14s, or, you know, into about 14 volts. And then you can tell right away if your alternator's working or not. And then you can just rule that out. Because if a diode in that alternator had shorted or opened, or something else was wrong with the alternator, if it's shorted, you could possibly get some parasitic load current draw off of that in itself. So that may be your problem why you're coming out to a dead battery, or the fact that it's just never charging it, and you're using the battery and you start it up, and then you come home and then it doesn't work. So, well, I hope this video helped you guys, and hopefully the next video I do will be on the bench. Thanks for watching.